Very good evening, everyone. My name is Mehreen Shamim, and I'm the curriculum manager at 1M1B. I welcome you all to yet another interesting session on machine learning algorithms, part 1. So before we start the session, we would like to extend our gratitude to IBM for partnering with us. The Grade 11 AI curriculum has been revised with the support of IBM and facilitated by 1M1B Foundation as IBM's partner. This initiative is part of our ongoing commitment to building and strengthening the AI teacher community in India, and these training sessions are a crucial part of this mission. Now let's welcome Ms. Neeru Mittal from SR DAV Public School, Delhi, a passionate educator and technologist with a remarkable journey in transforming education. She's a recipient of the National ICT Award for Teachers and the Delhi State Teacher Award. Her award-winning project, Reinventing Teaching Learning Methods for Effective Learning Outcomes, and her recognition as an exemplary Teacher of Change 2023 by AIM Niti Aayog showcase her dedication to shaping modern education. As a mentor to educators through NCERT, SCERT, DIET, and CBSE, she has influenced thousands and developing curriculum, conducting training, and authoring research. She is also one of the members in the AI advisory for curating the grade 11 and 12 AI curriculum. Let's give her a warm welcome. And now over to you, Neeru ma'am.
Thank you so much, Mehreen ma'am. That was a wonderful introduction. I would like to say, apart from all this, at my heart, I'm an educator, a teacher who really wishes to make an impact in the classroom. So let me just start this session by saying that machine learning isn't just a buzzword. It's a tool that's reshaping the way we think about problem solving, predicting values, and I would say doing magic. So together we'll unravel the magic behind machine learning and its potential to impact education, not only education, but real life. So now let me just share my screen with everyone. All right. So before we start, let's train the machine. Now, if you could train a machine learning model to do one task for you in your daily life, what would it be and why? This is a question for all of us educators here. Okay, now, everyone, I would like you to please join menti.com. Just type menti.com and type the code which is given on the screen. And I would really like to know, it's a fun question. If you could train a machine learning model to do one task for you in your daily life, what would it be and why? You can just, mix up the question. Mix up the answers. I hope everyone has understood. And my screen is visible. The question is, if you could train a machine learning model to do one task for you daily, what would it be? So I can see on the chat window if you are writing the answers. Okay, we can come back to that later. Okay, I have got 2 responses. Let me just check. Okay, cook for me. Okay, fine. That is something all of us would want to do. Search for our things, recommendations. Okay. So we have very honest answers coming from everyone. That's fine. There's a lack of time. So let me just, start. Okay, I have an answer from Miss Sheetal. I want to train my machine to check papers for me. Yes, that's the, I would say the problem we are all teachers are facing. The biggest challenge in our lives, the biggest task in our lives is this only. So let me just close the screen and let's further move to the presentation. So yes, it's so wonderful if we could have the machine train, have a model to do some task for us, and we could train it the way we want to do it. Now, teachers, dear friends, it's very much possible for us to train a machine and do a task, whatever we want to the machine. But the only thing is we need to train it. We need to, give it some data. So today's session will be covering ML, we'll be covering supervised learning, correlation. We'll also be plotting the line of best fit and also regression in real life. Where can we use regression? So before we start with the regression algorithm is an algorithm which is part of machine learning. What is machine learning? We all have heard about machine learning. It's a buzzword, as I said. Basically, it is a branch of AI. Predicts some results on the incoming data. Lots of data is given to it. And how is it doing that? Machine learning predicts data. But how? It is using data, and we also provide it with a lot of powerful algorithms. And these data plus algorithms, they help train the computers to learn on their own. And gradually, the predictions improve. Those of you who might be using chat gpt would agree with me, because when we're using our account in chat gpt, it keeps on learning from whatever we want, and after a point of time we get answers which are really tailored to our needs. So that is the power of machine learning. How does it do it? This is the crux of today's session. We are going to learn one of the algorithms of machine learning. How does it work? As it just said over here, we input data, lots of data is given. In the recent years, due to social media, due to internet, the boom in internet, we have a lot of data abundant on the internet. So machine learning uses data, analyzes it, finds a pattern. Now, this is very important. A machine learning algorithm will not be able to work if there is no pattern. So if I want to create an AI model, if I want to create a model to predict something, there has to be a pattern. And that pattern comes from data, which we also call historical data, data which is already available to us. The already available data is fed into the machine, a pattern is recognized, and then the prediction comes to work. After a lot of training, the prediction comes. And after prediction, obviously, the predictions may be okay, may not be okay. When the predictions are done, we decide whether the machine learning model which has been created is good or not. Otherwise, we do the things again. And prediction, if it is okay, it helps in decision making. Decision making in various fields, especially businesses, government, climate change, defense, lots of places we can use prediction for decision making. Most of us are computer teachers, I suppose. So we have done conventional programming. We all have done conventional programming. And conventional programming is also programming, and machine learning is also programming. Both of them involve a lot of coding. I would not say machine learning is something out of the blue. It is coding itself, but there is a difference. In conventional programming, we create a program, and we also give data. We provide program and data to a program, to in a language, for example, Python or Pascal or whatever, and then we are given a result, which is output. Whereas in machine learning, we are given the results. We give the machine the result, the data. The program or the code is receiving result and data, and then it is programming. So let us just take a very simple example, which we do in our classes, to convert a given reading in Celsius to Fahrenheit. So when we talk of conventional programming, we take input, which is what? Celsius. We apply the formula, and then we print the output. Whereas in the machine learning approach, we will feed a lot of values in Celsius. For example, -40, -10, it's given on the screen. Step 2 will be feeding the corresponding Fahrenheit values. That means we are feeding the input as well as the output. Both of them are being fed into the machine learning algorithm. And then these two values are passed to the machine learning algorithm, and ML program will now predict or convert any other Celsius value to Fahrenheit. So we're giving it input, we're giving it output, we're training it, and then we're getting the prediction. So that's how it works. So it is similar to programming, but on a different parameter. So in our classroom, how can we actually teach this concept? There are two very wonderful tools, Auto Draw and Quick Draw. So I'll just give a demo of one of the tools here because we do not have much of time here. So let me just go to Auto Draw, Quick Draw. Please do let me know if my screen is visible and if the sound is there.
Now
Yeah.
we can see.
So we have this wonderful research, I would say a research project, a worldwide project. It's a machine learning research project, which has been running for a number of years now. We can use this to teach our children or our students what is machine learning. So it's a fun tool. Let me just go through it. I'll just go quickly through it. It asks you to draw something. For example, it is asking here to draw street light in under 20 seconds. So I'll just go in and draw. Ma'am, is the
I see line,
okay?
or feather, or tree, or
Can
microphone,
you hear, ma'am?
or nail. I
Yes,
see
yes,
face,
we can hear.
or
Okay.
camera.
I just
I see
this is
line,
wrong.
or green bean.
I'm going to
Sorry,
draw it.
I couldn't guess it.
So the computer, the voice behind is guessing. Now, how that guessing is happening, I'll tell you in a minute. Now, draw lollipop. Okay, lollipop is very simple to draw. I think
I
so.
see line, or street light.
Not very good at
Oh,
drawing.
I know, it's lollipop.
Okay, then draw a watch. So I'll just draw a watch.
I see necklace, or circle, or frying pan, or spoon. Oh, I know, it's watch.
I'm getting very simple drawing assignment here.
I see moon, or circle, or frying pan, or onion. Oh, I know, it's sun.
Okay, this is difficult now. Mosquito. See, this
I see line,
activity helps
or
students
spoon.
understand machine learning in a fun way.
I have no clue what you're drawing.
So it doesn't
I
draw.
see glasses,
I don't know what it is.
or yoga, or lobster, or leaf, or trumpet. I see hand. Sorry, I couldn't guess it.
So now I'm drawing a
I
speedboat.
see line, or canoe. I see flying saucer. Oh, I know, it's speedboat.
So I got 4 out of 6 correct. Now I did not get this one correct. Fine. So how does it learn? Now, if I click on this here, I was asked to draw a mosquito, and it found out that it was a yoga mat, a hand, and the third best was a beach. What does it think mosquito looks like? What I'm talking about, it is this program, this machine learning software. This is what it interprets as a mosquito. And how did it interpret? Because all these mosquitoes were drawn by people like us, and with time it has improved. So earlier you could see the mosquitoes. This is the best way the mosquito can be drawn. So my mosquito was looking more like an ant to it, and it thought it's a yoga mat. So all this data, which you can find, all these drawings, these have been fed through years, and they have been used to train this machine learning program or research. So this is a quick draw, which we can use to teach your students how machine learning works. Now coming back to the presentation again, even AutoDraw is a similar tool which you can use in your classroom to engage and teach machine learning in a better or engaging way. Now coming to types of machine learning, there are basically 3 types of machine learning: supervised, unsupervised, and reinforcement learning. Now, when we talk of supervised learning, we have done supervised learning just a minute before, where we give data and we identify the data also. So we give data, we identify the data, we give input and output, and we ask the model to recognize what we have sent it. I'll just explain in a minute. The second type of learning is unsupervised learning. In unsupervised learning, we give the machine unlabeled data. We do not give them labeled data. We expect the machine to basically identify using different images, but we do not provide the images. Here, deep neural networks are involved. Then there is reinforcement learning, which we call a learning where decision processes take place, and there is a reward-based system. Reinforcement learning is more towards the crux of AI. So for this session, we are going to go on supervised learning. Supervised learning basically means, as I said earlier also, the machine is provided with labeled data. Now look at this diagram here. This computer, this machine, or this program is provided with labels of apples. Fine, images of apples, sorry. So we train the model with lots of images of apples. We ask the computer to just take in all this data. And we also tell the computer that these are apples. So after giving it a lot of data and the label, that is called the label data, the machine learning algorithm learns, okay, this is an apple. So after some time, when we provide it with a new data apple, it will recognize that this is an apple. So the model learns from the data which we provide. This is called supervised learning, and it is the most basic type of ML algorithms. So again, let's just go to one activity here. This activity is a very interesting activity which you can do with your students in class to make them understand supervised learning. There are 2 or 3 activities which we can do, but this is the most, I would say, easy, because it provides a reward. It provides a certificate at the end for the students. This is, the link is, it is in code.org, and it also trains, not only trains students in machine learning, how to recognize data, it also teaches students about how to keep our oceans clean. Fine, so there is a double, learning happening here. So how does this start? This is a robot, and pictures of the various articles are given, and we have to recognize, and we have to make the machine learn what it is. So let me just continue. If you can see my screen. Let's meet AI. This is the AI. It does not know if the object is a fish or trash, so we have to identify. So you can see everything is being given on the screen, very easy to learn. And now I continue. So is this a fish or not? The child can easily say it's a fish. This is not fish, not fish. And we can train. In between, you also get some good bites here. Again, this is a fish, not fish, not fish, not fish. Now, one thing which I would like to bring to your attention over here is that the more we train the machine, the better the prediction will be. Obviously, the more data we give, the better the prediction will be. So I'll just give a couple of more. And AI learns from your choices. If you make wrong choices, AI will repeat your mistakes. So let's do more training. This is not fish, not fish. Okay, now let me stop here and click on continue. Now this is going to tell me whether this is fish or not on its own. So it depends on how I have trained the machine. So let's go. Correct, correct. You can see it becomes so interesting for students to see all this. This is not. So it has taken socks as a fish. So because there's not enough training was provided to it. So this concept also has to come from this game. So it's a very interesting game which you can use with your students. Is my screen visible, ma'am?
Yes, ma'am.
Okay. There's another game. There is another software called Google Teachable Machine, which you can use. I'll not be able to show it here, but you can use this also in your classroom to teach the same supervised learning. So now coming to the supervised learning models, there are 2 basic types of ML models. This topic of supervised learning algorithms is very, very important, as well as it is a bit, I would say, complicated. So it's very important to learn the steps through which we can actually do this algorithm. There are 2 types of algorithm, regression and classification. The regression algorithm works with continuous data, like data like height, temperature, which have got some continuous values, salary, a number of hours studied, grades coming, and all that. Classification basically works on discrete data. For example, images of animals, number of employees, number of birds, and so on. So these are two types of supervised learning algorithms, and we shall be working on regression algorithms. So regression, basically, it's a statistical technique. It helps us to predict values, and there is a dependent variable as an independent variable. I'll just make you understand this now. Now let us consider the example of house prices. Fine. This is a real life example of regression. What are the factors that contribute to the cost of a house? Location, view, number of bedrooms, square footage. There might be other factors also nowadays, like for example, it's a greenhouse. Does it have a solar panel? Does it have a tank, and so on? So all these factors, if we consider them, they contribute to the price of a house. So all these factors can be assumed to be independent variables. That means these are variables which affect the price of a house, and the price of a house is a dependent variable. So basically, regression gives us a proper model where, depending on the values of independent variables, we can predict the value of a dependent variable. In this case, independent variables are location, view, number of bedrooms, and square footage. And the dependent variable is the price of the house. So before going to regression, proper regression, we have to understand correlation first, which is basically the foundation of regression analysis. Now you can look at this screen here. We have a chart, and we have a table here, and we also have a chart. So the table is clocking the study time in hours of a child and the grade in maths. So for example, if you can see, look at the values. 4 hours, the grade is 82, 3.5, 81. 5 hours, it's 90, big increase. 2 hours, it's 74. 5 hours is 88. So this is basically the study time which a child puts in and the grade which the child gets. So this basically is used to determine whether the study time input by the put in by the child actually increases the grade. Fine. To determine that, we have to plot a graph called a scatter plot. This is a scatter plot where the data values are plotted. So here we can see this is a grade on the y-axis and the study time is on the x-axis, and the plot is given over here. So this shows a type of a relationship between study time and grade. So correlation basically measures the strength of this relationship. This relationship is linear. That means the grade and the study time, they are linearly related. One increases, the other increases. One decreases, the other decreases, or the other way around. So this has to be there. So this is correlation. There are a number of types of correlations. The correlation can be positive. Positive when the values increase together, like in this case. Correlation is negative when one value decreases and the other value increases. For example, distance time. The relation will be time will decrease and time and distance, when distance covered increases, time obviously decreases to reach the destination. So correlation is negative when one value decreases or the other increases, and correlation is zero when there is no relation at all. So that is zero relation. So I would request everyone to write in the chat window about any instance. You can, you can just, give an example of positive, negative, or zero correlation. So when you look at this graph here, the scatter plot in positive, negative, it's very typical. We can identify very clearly this is positive, this is negative, and this is zero correlation. Now, before going further with correlation, another very important point which we have to cover is that is correlation and causation. Causation is different from correlation. Causation means there's a cause-effect relationship between two variables. Now look at here, alcohol consumption and smoking. Smoking causes lung cancer. So this is causation. You can see smoking causes lung cancer. Just a minute. So this is causation. Smoking and alcohol consumption are correlated, but they are, so smoking does not cause alcoholism and alcoholism does not cause smoking, but they are correlated. Someone who is smoking might also consume alcohol, or someone who is consuming alcohol might also smoke. But it doesn't mean that smoking leads to alcoholism or alcoholism leads to smoking. Whereas alcohol consumption and lung cancer have no relation at all. So it's very important to understand when we are working on regression, there has to be a relationship between two variables, and this relationship has to be a correlation relationship, not a causation relationship. How do we measure the strength of the linear relationship? And that is done by Pearson's R, or correlation coefficient. Now, looking at R, the first time when I saw this formula, even I was scared. It's a huge formula. So we have the R is a Pearson's coefficient. Basically, it measures the strength of the linear association. Correlation means the linear association, and Pearson's measures what is the strength of the relation, so that we can actually predict. We can actually say, depending on the strength, how strong or how weak the relationship is. So if you look at the formula, it's a bit scary, but we are allowed to use Excel to find out the Pearson's correlation coefficient, and it is very easy to do that. Look at the example here. We have 6 people with different age and different weights. So to calculate R for this is a demonstration of calculating R. You have age, you have weight, X is age, and Y is the weight of a person. Using, again, Excel, we use the formulas in Excel. So X is this column, Y is the weight column, X into Y. Then we take X squared, we take Y squared. We take all the parameters which are given in the formula. And we simply apply the summation function here, total function here. So we get the total of X, we get the total of Y, we get the total of XY, total of X squared, total of Y squared. And we form a table and we put it here. It is easy to comprehend in that way. 6 here, or N is 6 here, because the total number of people we are taking into consideration here is 6. It's a small set, but fine, we're taking it as 6. Moving forward, we just have to type this formula into the formula bar. In one of the cells, we can go to one of the cells and type this formula, and we get the value as 0.35. Using this formula, we have the values of age, weight, and their relationship in between. Now, 0.35 is the Pearson's correlation coefficient, but what does this mean? It means 0.35 means that the age of a person, that means older people do not necessarily be heavy, but there is a mild association that the older you get, you gain weight. But it does not mean that as soon as you get old, you gain weight. So, but there is a simple explanation to this, that there is a mild association. So 0.35, the value of 0.35 means there's a mild association. How? So Pearson's coefficient value interpretation can be done here. If the strength of the association is from 0.1 to 0.3, it is a small association. That means little association. That means both the values are correlated, but in a smaller manner. Similarly, it goes for negative. Medium means 0.3 to 0.5. That means the two values are related, but in a mild manner. And large means there's a strong correlation between the two values, 0.5 to 1. Pearson's coefficient works from 1 to -1. The value can be from +1 to -1. So if you look at this, if the value is 1, it is a perfect positive correlation. That means the relationship is very strong. It's a perfect relationship. High positive from 0.9, then low positive 0.5, no correlation 0, and so on. So we have all this data. Depending on the Pearson's value, we can establish what the correlation is between the two variables which we are taking into consideration. I hope there are no questions till now, or you can just post your questions in the chat window. But then there are some requirements for the Pearson's coefficient. We also call them the limitations of the Pearson's coefficient. The scale of measurement, that means the intervals. We have to take regular intervals. For example, you can look at the chart here. The range is 1 and the frequency is in the interval of 10. The range is in the interval of 1, frequency is in the interval of 10. So there has to be a regular interval in both the values. That means if you're taking both the values, the intervals have to be regular. The variables should not be they should be equally distributed. That means if you look at the slope of the line in the beginning and the slope of the line at the towards the end, it is almost the same. So the increase has to be proportionate, or decrease for that matter. The association should be linear. Linear means when one moves forward, the other also moves forward. The value changes accordingly. Either it is positive or either it is negative. It should not be non-linear. That means if there is no association, it doesn't work. And if it is non-linear, that means one value does not increase when the other increases or decreases, then that is a non-linear. So the relation has to be linear. Now coming to this, there should be no outliers. So first of all, what is an outlier? Outlier means when we are predicting values, the predicted values as well as the input values might be different. So outlier is a value which is completely out of range from with respect to these variables. So there should be no outliers in the data for Pearson's coefficient. Now we come to regression, the main topic which is here, regression analysis. Basically, as I mentioned earlier, it is basically creating a model or coming up with a model which predicts the value of a dependent variable depending on the independent variables. It understands what changes are there on the dependent variable depending on independent variables values. So for example, we can predict students' test scores based on study hours, as we just did. We can forecast sales using advertising spending and so on. So when it actually involves creating a model, an AI model. How do we do that? Now this is a difficult part, but again, it becomes easy using Excel. Now look at this line here, the equation of the line. When we are having a line, y equals to a plus bx plus e. Here, a is the intercept of the regression line with the y-axis. B is the slope. That means with every change in y, how much x changes, that is b. And E is the error. We are not talking about error here. Error means the difference between the actual value and the predicted value. We'll come to this in the next part. So what we must understand here is, in a simple linear regression model, y depends on x, fine? And the regression line of y on x is y equals to a plus bx plus e. This is a model. This can be used with new values of a, b, and x to predict the value of y. How do we do this? I've just done it beforehand. We have to plot the historical data, find the equation of the line, and this equation of the line can be used to predict new values. Now, again, let me just go to Excel now. I'll show you the demonstration of how to create this. What I've done here, I've taken the same table which we used earlier of age and weight. So we have serial number, age, and we also have weight here. Now, after plotting, and inputting these values, what do I have to do? Ma'am, is my screen visible?
Yes, ma'am. Yes, ma'am.
Okay. So what do we do here is, because we want to see the relationship between the age and weight, so we will plot a chart using these two values. I'll select age and weight. Simply go to the chart option, insert, and I'll plot a scatter chart. You see how beautifully it has come up. So this is a scatter chart which shows me the age as well as weight. Now, how does this work? We have to make a few changes here. So I'll go to the plus sign and I will add the data labels. That means what are the values? It's up to you. What I really have to add importantly is the trend line. The trend line has to be linear. We have linear, exponential, and a number of other options, but we have to go with linear. And you see the line has been created, the linear line here, right? But again, we have to make some more changes here. Let me just, because see, we are starting, the values are starting from 21. So the first values from 0 to 20, the chart remains empty. So let me just make a few adjustments here. I double click on this. And I get the axis option. In the axis option, I have to change the minimum to 20 because the starting value is 21. So I'll just make it 20. And you see the chart shifts a bit. This is the line regression line. I can change the chart title. Those are trivial things we can do. But how do we get the equation of the line, as I mentioned? So I'll just again go to plus, go to trend line, and go to more options. When I go to more options, I get a number of charts here. You can see logarithm, all the charts are very clearly given. It's a powerful tool in Excel. I simply go and click on display equation on chart. So I'll click on display equation on chart, and here I get the equation. This is the equation of the line. Now here we can see that the value of A is 0.3491, and the value of X has to be input, and the value of B is 56.414. The two intercepts are given. So one is the slope and one is the intercept. So this is the model. This is the model which has been created for this age and weight problem. So once I've done this model, once I've used this model, I can put new values of A, B, and X and find out. Now let me just verify whether the values are correct or not. So I'll just go to any cell and type the formula is equal to slope. Slope is an inbuilt function in Excel. Choose the age field, then put a comma because this is a formula. Choose the weight field and press enter. So I get 0.3451, the same which I'm getting here in the equation. So this verifies that the slope is 0.345. And then I put the intercept value equals to intercept value. Again, I type the function intercept. This we are doing to create a model, as I mentioned earlier. Again, I'll select age, put a comma, select weight, and an enter. So 10, this is my value of this thing, intercept. So that is how I have created the regression analysis, the regression line. This is the line of regression which we have created, and this can be created, and we can have new values of X, A, and B to predict the answer. Now, regression line creation is fine. Now, in the earlier equation, in the earlier slide, I spoke about the error part, the E part. We call it the residue, or we call it the E. Basically, it is a difference between the actual value as well as the predicted values. Obviously, there has to be some difference. We do not have a perfect model. So if you look at the chart here, you have this line of regression, and these blue ticks, the blue points here are called the data points. This is the actual plot. And we get a line of regression which includes maximum points. That means we want, this is the best line of regression. That means this is the best line which fits this model. Fine. So it has to pass close to the data points. It is also known as a line of best fit. How do we find this line of best fit? We use the least square method. This is again a statistical method. Now, if you look at the chart over here, the green values are the actual, the green dots are the actual values. Fine. Let me just show you. The green dots here are the actual values, and the red dots are the predicted responses. You can see that the line of regression ran through the predicted responses, but there is a difference. Fine. So this method tries to minimize the difference between the predicted as well as the actual values. It is a proper mathematical equation which is again done, but again we can use Excel to find. So let me just show this. Now coming back here, I'll again go to the chart, put a plus sign. In the trend line, I'll go to more options. In more options, go to chart. Make sure the chart option is selected here because the other two are formatting options. And I can click on display R squared mean value on this chart. When I click on that, you get R square. This is a bit different from the least square method, but again, this gives me the measure of how much difference is there between the predicted values and the actual values. So here R square is 0.1205, which is negligible. So that means this is the best line of fit as of now. You give it more data, it trains better. I hope everyone has understood this part. Now going forward, I'm just showing you one model which we can find. Now you can see over here, there's a cigarette, and the byproduct of cigarette smoke is carbon monoxide. This is the equation. C equals to 3.0 plus 10.3 N. So if the nicotine amount goes up by 1 mg, that means the carbon monoxide in the smoke will increase by 10.3 mg. So C here is what is the carbon monoxide level. So if 1 mg increase happens, because you can see in the equation, if it is 1 mg, 10.3 into 1, it is simply 10.3 will be the amount. And if the nicotine amount is 0, the carbon monoxide level in the smoke is 3.0. So it really predicts how much amount of carbon monoxide comes out from this. The next topic here is linear regression models. We have, as I spoke in the beginning, there can be single variable dependent variable, and there can be multiple dependent variables. Simple linear regression we have done. Like even here you can see there is body weight and height. It's a linear regression, single equation. But when you look at the model on the right, it is called multiple linear regression. Here, the dependent variable depends on multiple factors. So what I've tried to do here is, we have tried to predict the heart rate disease of a population who bike to work, who use a biking to work, who use a cycle to work. This would be single relationship, but we have also taken into account smoking. So if the smoking factor is there with biking, the results will differ. So when we have a minimum smoking population, we have 0.53, then the line is closer. That means we have lesser instances of heart diseases. The heart disease rate increases as the smoking percentage of the population increases. So this is multiple linear regression. We can have both types of regression. In our syllabus, we have to know what is multiple linear regression and what is simple linear regression. We must know both of them. Then linear regression or not, what are the advantages to implement? If you're using Excel, we're using charts, it's very simple. It is efficient to train, but disadvantage is that it has to be linear. We cannot have anything which is not linear, and it is sensitive to outliers. So the range should be in between the variables. So this is also a disadvantage of linear regression. On the screen now are listed the real life uses of regression. There are a number of real life uses. We studied the first one where we had the house and the price prediction. So I'll just go forward from here. Now we have a quiz for everyone. Ma'am, do we have a time for the quiz?
Yes, ma'am, you can take.
I hope everyone has understood. If there are any questions, you can please put in the chat box. I'll take at the end of the session. So this is a quiz I've created on quizzes. It is on the concepts you have learned. I would request everyone to please take part in the quiz. So you can see over here, join using any device. You can use this. I can again copy and share it in the chat window. Is my screen visible?
Yes, it's visible.
Okay, there was a message. So click on this and please enter the code 015905. I would request everyone to please enter the code. Okay, I'm getting Preeti, Nishant, RS, so 4, 5. We are having a number of participants coming in. 5. Only 5. I think we have many participants. We have 34. 32. Kindly join. The questions are not very tough. It is just a quick recap of what we have done. I'll just wait for 2-3 minutes more and then we can start. Kindly join quickly, everyone. Okay, now I think we have enough. Let me just start. We don't have much time. So I'm just starting the quiz. Okay, I'm getting good answers. This is my test also, how much I've taught you. Carefully, you should not be getting wrong answers. questions. I think all of you have answered all questions. Let me just check. Yes, almost. So in another 2 minutes, I'm going to end and we'll see the winners. we are having third is Mr. Kuldeep Vishal. Second is RS. I'm not sure who that is. And the first is Najma ma'am. So that was the quiz. I hope all of you have gained some knowledge. I'm ready for questions.
Preeti ma'am, some programs are given in the curriculum. If you open the curriculum of grade 11, there are some programs as samples given for regression, classification, and clustering. Just look into that. We have provided the links. When you click on the links, you will get the data set along with the programming.
We can share the program. It is there, but that was I think for advanced learners, so I did not include it in here in my chat in my this thing. But it is there. If you want, I can share. I would like to add here, ma'am. The Excel part can be taken for low code for students who are not good at coding, but the Python part can be taken for students who are good in coding. So you can go in both ways. If you go to the book, you have both parts given there.
All right, I think we can now close the session. Thank you so much, Niru ma'am. Session was very nice, and thank you teachers for joining the session.